The geological map of Western Australia encapsulates the state's remarkable geological record, which spans almost 4 billion years, but it cannot convey the dynamics of its geological evolution. This animation of the state geological map in 100 million year time slices highlights the relationship between the major tectonic events and the large-scale mineral systems that have created the mineral wealth for which the state is renowned. The evolution of Western Australia begins with the creation of the oldest crust in the Narrated terrain, which is about 3.7 billion years old, and the earliest gold and base metal mineral systems, which occur shortly after in the East Pilbara. Plate tectonics is interpreted to have begun about 3.1 billion years ago and is associated with gold, base metal and PGE deposits in the East and West Pilbara. This also leads to the first accretionary orogenic events recorded on the Pilbara Craton and is then followed by the early stabilisation of the Yilgarn Craton. Between 2.8 and 2.7 billion years ago, the Narrated terrain is accreted to the Yilgarn Craton, followed by the formation of vast nickel sulfide and orogenic gold mineral systems upon which the state's early mineral wealth was built. At about 2.5 billion years ago, banded iron formations are deposited in the Pilbara, followed by their subsequent deformation during the ophthalmia orogeny to provide the essential ingredients for the iron mineral systems that have underpinned the state's most recent resources boom. The formation of the West Australian Craton during the Glenberg orogeny about 2 billion years ago creates VMS and orogenic gold mineral systems along the northern margin of the Yilgarn Craton. The assembly of the North Australian Craton starts about 1.9 billion years ago and results in the formation of orogenic gold, base metal and PGE mineral systems in the Kimberley and the Tanami regions. The collision of the West and North Australian Cratons and an intracratonic reworking at about 1.8 billion years ago during the Capricorn orogeny then results in the formation of orogenic gold and base metal deposits within the Capricorn origin. The assembly of Proterozoic Australia occurs between about 1.4 and 1.1 billion years ago, starting with the collision of Proterozoic Western and South Australia during the Albany-Fraser, Mount West and Musgrave orogenies. This is followed by accretion along the western margin of the continent during the assembly of Rodinia, recorded by the Darling and Pinjarra orogenies. Extensive magmatism at this time results in the formation of large mafic-hosted nickel, copper and PGE deposits. Subsequent Proterozoic events in Western Australia, such as the Edmundian orogeny, are entirely intracratonic and are due to far-field or deep-seated events. The breakup of Rodinia about 800 million years ago and later intracratonic orogenesis during the Patterson and Peterman orogenies are largely responsible for the formation of the sedimentary copper mineral systems of the Centralian superbasin and the intrusion-related gold systems in the Telfer area. At about 570 million years ago, the most prominent impact crater in the state, the Shoemaker structure, is formed. Finally, the Phanerozoic evolution of the state is characterized by the formation of onshore and offshore sedimentary basins related to the breakup of Gondwana, which host vast fossil fuel reserves as well as significant base metal mineralization. This period is also characterized by numerous impact cratering events, most of which are buried, and also the reactivation of old basement structures during the Alice Springs orogeny. The most recent and extensive mineral system in the state is associated with Australia's separation from Antarctica and its subsequent northward drift. This results in deep tropical weathering and supergene enrichment of a wide variety of mineral commodities such as iron, gold, nickel, aluminium and uranium. The resulting regolith layer now obscures the bulk of the bedrock geology of the state.